Hello, welcome back to the PICO-8 tutorial series. This episode, it's a new episode for me. So I'm going to go into our tutorial directory. The last one that we had just worked on, moving around the camera with the map, is our tutorial 2. I'm going to load up tutorial 02 here. But I'm going to save this new one that we're going to add collision detection to as 03. Just so that these get segmented apart a little bit. Like I talked about last couple videos, roll your saves. So what do we have right now? What we have is being able to move around this map in various directions, but we can walk through walls. We also have a slight problem where if we hit the edge, we can't move to the edge. So let's fix first not moving to the edge, right? And then we'll fix collision detection. So first thing, let's fix not moving to the edge. Let's turn back on the debug statement we had before so we can see our box. So what we want to actually do is, if the box is here, we want to make the box allow me to move to the edge, right? So if it's slightly off, then we want the box to be back to being pushed. If I come into our move player function, and we say, if x is less than box y, then we move the player. We move the camera. We lock the camera if we hit the edge. But if we set the camera to 0, then we're going to change the box edge here. We'll work through this. We'll work through this slowly. I'm going to set it also to 0. And if we set the camera to 128 all the way to the right, we're going to set the box edge to 255. Otherwise, okay, if we're not at either edge, we're going to set the box X. This is actually X2. Okay? If we're not at either one of those, we're going to make sure the box X and X2 is back to what we defaulted it up here to be, 32 and 32. I'm sorry, 32, and what was X2 was 88. Okay, might be easier to see this in action, okay? We're gonna have to make a slight adjustment, I think. Because we allow it to change for just a second, but then it breaks. Also, this one is going to be 127. The box doesn't move with the camera. We don't have to worry about that. Okay. I'll have to set these to less than or equal to. Is that now we're working. Let's see if we can actually move in those values. And now. So the box is doing visually on the screen what we want it to do. We already have the code that keeps us in the box working. But what we want to do is allow the box to grow if we're allowed to move in that area. And then once we leave the area, we want the box to shrink back so that we go back to the pushing logic that we have. I'm going to do this to the Y. Down here. So if it's less than or equal to, greater than or equal to at this point, because we need that to be equal so that we don't reset this constantly, because we do move the player if they get outside the box. So it's 0 and 127. So if we're on the top, we're there. If we're on the bottom, we're there. And then we reset it if we're not pushing either edge. And again, I meant Y2 up here. Now, we got this great big box of area we're allowed to move in. And then we go down here and we broke that one, and we broke that one free. But we can reestablish that one. Now we can move all around down here. Go make sure we're working in every direction. All right. So we've got movement code working pretty well. But we have to add collision. So let's go turn off our debugging. Oops. Can't see what I'm typing. FALSC. False. All right, there we go. Now we're back to this. So I hope this was clear. I can go over it one more time, but we already have this box set up that the player has to stay in, and we reset the camera before we draw the box on the screen. So we know it's in a fixed location. And if we know the camera is touching, that's what the equal sign is for, touching an edge, a wall, not the edge of the screen, but the edge of our map zone. Okay, we know if it's touching one of these, then we can let the box edge expand to the edge of the screen. So this is the edge of the screen, not the edge of the map. This will never change. If we add more map here, those numbers will get bigger, but these will not. Okay, the box that we set up in the player is always locked to screen space, but the camera is going to allow us to scroll the whole map. So if we had more in these directions, I'll have to expand that. I'm not going to worry about that for the moment. What we are going to work on is collision detection. So we have this sprite that we know we want to collide with. We have this sprite which we want to be able to walk on top of. So what we can do is we have these flags down here. You see at the bottom as I hover over this one, I can check that because I'm unlisting. But the important things to note down here when I'm hovering over that is flag 6 right there. This one's flag 0, 1, 2. Let's just say I'm going to grab flag 3. The screen. Look at all our colors here. All right. Use the red flag, which is flag 0. Okay. You can use any of them. In fact, I don't want to use 0 just because it might get confusing in code, so I will use the green. Although green means go, in our case, it's going to mean stop. Flag 3. So that is flag 3. Don't worry about that 0x8. there. That comes in later. We're not going to get into that today. What we want to do is we want to know what is the sprite that the player is underneath. So, how do we do that? Let's go over to map. We have an imget. Gets a map value. Takes an X and a Y. Alright? Let's go look that up on the PICO-8 wiki. Gets the number of the sprite assigned to a cell on the map. The X column coordinate of the cell, the Y coordinate of the cell. Okay. So we actually, we think about it, we have 4 of these to check. Okay? Because I know we got this eyeball. That's our sprite. But really, he's a box. We're drawing him as a tile. Okay? He's in a box. He could hit the map on this side, on that side, on that side, or that side. Any one of those 4 sides could hit a tile. So what we need to find out is by checking these corners. Okay? In fact, I'll color them in a green, but I'm going to switch to red. These 4 corners represent the 4 locations we need to check to see if the player is touching bricks. And if that's the case, well, then we can't let the player move there, can we? So what we need to know is when he's on the grid, right? Let's draw the map in here. So here's the tile grid of the map, and the player is right there. And this is getting complicated, but that's okay. Complex, but not hard. What we need to do is get these 4 squares from the map and check to see, are you bricks? Are you bricks? Are you bricks? Are you bricks? And if they're bricks, then he cannot move there. Whatever he tried to do, not allowed to do. Okay, so let's try to do this by simplifying some of the complexity. All right. First of all, we're going to do what we call refactoring. See how I did box down here? X, Y, X2? We're going to do that for player. We're just going to call him PL. We're going to do that. And then we're going to change this. So that's the player's X, the player's Y, and the player's sprite. Of course, I have to go back now, and I'm going to copy this PL dot, because everywhere we've used X and Y, or S, we have to actually put in there. And you know what? This might be a good time to go ahead and just bite the bullet and switch to the simpler notation for those statements. Okay? Going to do the same down here. The only reason I'm doing this is to make these things a little bit clearer when we start talking about X and Y. Whose X and Y are we talking about? You can see it's getting kind of crazy. That's just changing camera. That's fine. And yes, we should go back at some point and do the same to the camera. Not too worried about it because the camera only has an X and a Y. And it's already CX and CY, so we're okay there, I think. But you may go ahead and do that if you want. Missed one right there. Saving it, running it. Oh. So, got an error. It says syntax error. Line 39, tab 1. So I'm on tab 1. And I'm actually at line 39 here. It put me right there. But you can read the line number down here, 39. And I accidentally deleted the S that goes there. Okay, we're back. We broke nothing. That's called refactoring. What we just did is called refactoring code. When you go back and you make your code easier to understand, but you don't actually change any of the logic. You want to make sure when you're refactoring, you don't try to change logic at the same time. Do all of your refactoring, make sure it works, then add the new logic. So what we need to do is we need to do this check. Okay? To figure out, after we move the player, okay, which are these two, we move the player and we move the player, can they move there? Right? So all of this map code checking, everything we have to do is going to go right here. If map collide, right? Then, okay. So what I did here is I just said, hey, this is going to be a lot of complex stuff that we got to put in here, right? We have to get those four corners. We have to check those four corners. We're going to have to deal with them in there. So if map collide, then do all this. Of course, this doesn't mean anything. Let's go over here. We're going to go to our draw map page, and we're going to add this new function. Right? Let's think about what we need, though. We need those four corners, right? So we're going to need an x1, an x2, let's say y1, and an x2, and a y2. Now that's scrolling a bit. That gets annoying. I'm just going to hit enter and space and line these up. Okay? So map collide is going to take an x1 and a y1 and an x2 and a y2. Well, let's go back to our code here. What are these going to be? Well, it's going to be the player's x. Right? Now what's x2 and y2 going to be? Well, it's going to be the player's x plus how wide is the player. Right? We come over to our sprite. It's actually 8 pixels wide. But this pixel here, we do this on the very first one, right? That's XX is Y is 0, 0. And that is 0, 7. So we could do this, and I've said that we could do this a couple of ways, right? When we say XY, X1 and X2, it gets confusing, doesn't it? Do we want this 7 and we count this row? Or do we want the 8 and we don't count it? Well, we know he's 8 wide, right? That's our sprite. 8 wide, 8 tall. So why don't we switch right now and say, this is width, this is height. And we can just take out the x1 and y1, and we might actually be able to put this all back on one line without scrolling. X, y, width, height. Come back over here. 8 and 8. We may want to come up here now that we have this player object. We may want to say, hey, you know what? The width is 8. The height is 8. The width is 8. The height is 8. Okay? So we have up here players X, Y, height, and width. Okay, so the last thing, I keep hitting the wrong button. To make this work here, we're going to have to return something. And we're going to return false to start. Why false? Well, if map collides, then we're going to handle the map collision. But to start out, we don't have any collision detection working. I want to make sure we didn't break anything. I don't want to hit run. We're still moving around the screen. We can never collide because we never return true. If I default that to true, we can test what should happen if we're colliding. Well, we shouldn't be moving, should we? So, what we're really going to have to test is not where the player is, but where the player wants to be. If the player can't go where they want to be, then we don't let them move. So at the start, we have pl.s, we reset to 1. We're going to here, and we're going to put in a pl.x 60 and another y 60. But we're going to call them OY and OX, meaning old X and old Y. And then right at the start, before we do anything, we're going to say pl.oldX equals pl.x and pl.oldY equals pl.y. Now we've saved those values off. Now we can change it. Now we can test the change. And if the change fails, for whatever reason, they hit the map in any direction, we just don't allow the move to go through. How do we do that? We set them back to their old values. Now, the sprite still changes because we're trying to move, because we're holding the buttons down, but we can't move because the game thinks we're colliding. Oh no, we're colliding. Alright. Now we have to actually do the collision code. So what we're going to do here is I'm going to say sprite 1 equals mget. Okay. mget will tell us the sprite number assigned to the cell on the map. Make that bigger in case you can't read it. But this is cell X and cell Y. We're passing in screen X and screen Y. All right. So let's go ahead and say X divided by 16 and Y divided by 16. That's sprite 1. Sprite 2. Well, it's going to be very similar. All right. This is our sprite. X, Y. Call that S1. Call this S2. Okay? So this, we don't have the X2 and the Y2. What we have is the width and the height. So to get from X to here, we add the width, right? This is X plus W. Now, we have to be careful because the computer might want to do W divided by 16 and then add the X. It might do X plus W and then the way we want to do it. We have to be certain. We're going to need to put that in parentheses. And because we're getting a lot out, I'm going to take out some of my spaces. There's something we now know for sure. We don't actually want the X plus W. We want the X plus W minus 1, right? Because the width is 8 pixels. But we don't want the 8th pixel over. We want from the start of the 7th, right? Again, think about it back to here. If we're here, and this is pixel 8, right? It says at the bottom, that's pixel 8. And we go over to here, this is the pixel that collides. It's 15. It's not 16. That's part of this sprite. Pixel 15. By passing in the width, though, and not X2, we know exactly where that's going to wind up. And for S2, we're not going to change the Y. However, for 3 and 4, we're going to do the same thing on the X, but the Y is always going to be plus the width minus 1 in both cases. And I'm just going to let this scroll here rather than entering a bunch of extra lines. So now we have the 4 sprites the player is touching. What are we going to do with that? Well, go back to graphics. Remember we set that flag? There's an fget. If there's an mget, there's an fget. Gets the value of sprite flags. And we're not going to look this up in the wiki. We just have to pass in the number of the sprite that we're checking. So we got sprites 1, 2, 3, 4. So these sprites are going to be one of these. That's all that's on the map right now. Or if there's no map, if somehow they gotten off the map, it's going to be sprite 0. The fget will get the flag set. So we can pass in the flag here. You know what? Change my mind. We'll look this up. Okay. So the number of the sprite is in, which we got right there. The F is the flag index, which is the number, which we set is flag 3. So if fget sprite 1 flag 3, then return false. We hit a wall. And guess what? We're going to do this for all 4 sprites. And make sure we get an end on that. S2, S3, or S4. So we've grabbed out 1, 2, 3, and 4 by calculating the heights and the widths of where the box is on the map. And then calculate out S1, S2, S3, and S4. By checking the flag. If flag 3 is set, we return false. Oh, I'm sorry, I got it backwards. False should be no collision. True. We hit something. We hit a sprite that has flag 3 set. Okay. We're off a bit. And we move through there. So what do we need to fix? Well, first of all, let's try to fix the top corner. Because I know what's going on with the second one. We didn't do anything with the camera, did we? No. We have to fix the camera. 1, 2, 3, and 4. So, let's go to the console real quick. And I'm going to type CLS to clear the screen. You can run these statements at the prompt at the console. So if I say, what is 8 divided by 16? How about this? Print 8 divided by 16. Okay? Just put it in print and type it out. That's 0.5. Interesting. Okay. What is 7? 0.4. Okay. 0.4. What is the mget of 0.4? We're going to say y1. Oh, we got our print. Nine. Okay, so it's sprite 9. Let's set it to 0. Also 9. So it's 0.4. Is getting 9. I go into our map. So I'm thinking 0.4 is in this tile somewhere, right? Sprite. That's sprite 9. Okay, that's working. This is 1. And 1. Let's go back to our console. If we get 1 in 0.4, it's 9. Cool. 1.1 is 9. Cool. 1 is 13. 9. So what error have we made here? I thought at first maybe it wasn't the flooring, right? That it was rounding off, but it looks like it's reading okay. If we ask it to give me 0.9, 0.9, it's giving us 0.9, 0.9. So let's go. Remember I told you I promised live debugging, right? You can go to the keyboard, you can try things out. We can also try things out here. We can turn on our debugging, and we can add these print statements to our code. Now we can go look up print real quick. Takes a string that we want to print. We can also give it an XY, where to print it on the screen, and the color. Okay, good to remember. So we want to print X is, and we'll use, I believe it's, might not be wrong. Hold on. What we need to do here is strings. Joining strings is ... Okay. So let's just make sure this works, right? I'm going to go with white. What color is white? White is color 7. And let's print the Y. Player Y. Now, we're going to print this a line below it, so I'm going to go 8 for my Y. You can see we're 60-60. There we go. We're moving down. So here, our Y became 16, and we can't go any higher. And our X became 16, and we can't go any further over. Okay. So we are there, and we're reading the numbers correctly. We are 16-16. Let's look at the code we've got. And sprite 1 is X divided by 16 and Y divided by 16. Oh, well, there's our mistake, isn't it? Sprites aren't 16 by 16, are they? They're 8 by 8. Why did I ever put 16? Who knows? We'll change all the 16s to 8s because that's how we convert. We'll run this again. Now we can get to 8 and 8, and we cannot move up in the corner. However, we're not taking the camera into account. So, notice as we move, we actually stop changing, right? Because that's the way we did it. We're not outside the box. We're always trapped in the box. The map moves, the player does not, right? We're moving the map underneath the player. So, what we have to do is take that into account. Well, is there an easy answer before we do all this math down here? What if we just say camera and then when we get done, just so we don't mess up any other code, we set it back. Now, I don't know if this is going to work. I actually don't. I don't know if mget and mset will take into consideration the camera. And it doesn't look like it is. Well, that is unfortunate. But we can do what the camera was doing manually. So, what we can do is say, hey, this X minus equals the camera X. And this Y minus equals the camera's Y. Well, isn't this a predicament? Did I want pluses? I wanted pluses. Leave our debug up for now. There we go. Check all our corners. Now we can't scooch along the edge because if we try to go diagonal, it does stop us. We can fix that in code if we wanted. I'm not going to worry about it in this particular demo instance. But as you can see, we're able to move around and collide with the walls. So this is really what the camera does, right? It offsets all the equations. By modifying this before we do our math down here, we can do what we would have done by trying to set the camera. Would have saved us some time, but you know, it is what it is. Go back over here Let's turn off our debugging. Save that as tutorial 3. This looks pretty clean already. We look at our player code. All we had to add was this little bip. And now we have a map collide function that can not only be used for the players, right? This map collide that we wrote, this can be used for any box we want to check. So this could be used for any kind of enemy logic. This can be used for any kind of projectiles or bullets or things bouncing around the screen. You know, if we had a ball bouncing around, it would also work for that. And that's really the advantage of putting that into a function like we did, instead of just putting it in the player move code and doing it right there. It allows us to reuse it for everything. All right, so that's going to be that. At the time I'm doing this one, I haven't figured out the next lesson step that I'm going to upload, but we'll probably either look at switching to a platformer type system now, because now that we have collision, now that we have collision working and scrolling, we can start looking at a platformer, a side-scrolling platformer, because now we would just have to implement gravity. Once you implement gravity, everything else here will work. So we have the logic for jumping and stopping and landing on top things. We just have to do it all manually. So we need to look at platforming is probably what we'll look at, since that's a lot of initial games are platforming, but also coming up shortly, enemy and some kind of projectile shooting. All right.